Now, if you are new to this channel, please kindly subscribe and share. Please, that's how to help this channel, please. Now, today, we want to talk about the integration by trigonometric substitutions. Now, this aspect of integrations, we need to pay a good attention. Now, when you have an integration questions like this, how do we do it? We call it trigonometric substitution. There are things we have to take note when we want to solve this kind of integrations. Number one, there are three things we work with. We work with sine, we work with tan, and we work with sec. These are the three things we work with when we are dealing with this aspect of integrations. We work with sine, tan, and sec. That's number one. And number two is that we work with triangle. Now, if they give me this kind of questions under integration by trigonometric substitutions, the first thing to do is that draw your right angle triangle. Put your angle here. And you put your angle here. Now, take a look at what you have here. You are having a square minus n square. If I'm having something like this, you know, in a normal Pythagoras theorem, we work with Pythagoras theorem here. If I have a Pythagoras theorem, this will be my hypotenuse. You don't need to tell anybody. This must be my hypotenuse because hypotenuse is always the highest of all the sides, and this is going to be my hypotenuse. And if this is going to be my hypotenuse, that means this is hypotenuse, the A will be here. Okay, so we are given something like this. First thing you have to do is that this is hypotenuse. Hypotenuse is A. You will not think about where will you put your x. Is it here or here? But do not forget, we work with sine, tan, sec. If I put my x here, assuming I put my this that join this and this together, because this is actually hypotenuse, and this is opposite. This is adjacent. Adjacent is x, and for us to have this, that is cos, that is car, and I don't have car here, so that means you cannot put your x here. But if I put the x here, this is opposite. Opposite is x, hypotenuse is A. And what is the trig ratios that join these two together? That is actually sine. Sine join them together. That means, and out of these three, sine is one of them. So that means I'm going to use sine here. That means sine theta equals to opposite x all over hypotenuse A. That means my x equals to, if you cross multiply, A sine theta. It's very, very important. That is my x, which is A sine theta. After I've gotten my s, when I cross multiply to the A sine theta, so I will differentiate it. I'm going to find the s d theta. The s d theta. That means my dx d theta is going to be, what is differential of sine theta? That is cos theta. It's going to be A cos theta. After I've done that, I will cross multiply. If I cross multiply, that means if I say over 1 here, that means the x equals to A cos theta d theta. When I cross multiply, it gives me the s equals to A cos theta d theta. After I have done that, what is the next thing to do? Differentiate this and the s d theta. The relation of sin theta is cos theta. And we cross multiply. The s equals to A cos theta d theta. So you now come back to this place. Integral of A squared minus S squared. What is our dx now? Our dx is A cos theta d theta. That's our dx. And I have known my x. My x is a sin theta. That means a squared minus my x is a sin theta. I'll substitute for it. A sin theta all squared multiplied by a cos theta d theta. A cos theta d theta. So the next thing now is that after I've done that, I just say integral of a squared minus. So this one will give me a squared sin squared theta multiplied by a cos theta d theta. And we know that the a square is common here. And just say a square into brackets, because a square is common, I want to factorize it. 1 minus sin squared theta multiplied by a cos theta d theta. A cos theta d theta. So the a square here is common. I factorize it. Open a bracket because this one times this time. It will give me back multiplied by a cos theta d theta. So what do we do there? You can just say from that place let me say integral of I can split this square root on them multiplied by integral of 1 minus sin square theta, it is cos square theta. Cos square theta multiplied by a cos theta d theta. So that means this cancels this and this cancels this. Now you have a cos theta multiplied by a cos theta d theta. Now after this, what do you do? You have, when you multiply these two together, that will be a times a squared cos square theta d theta. Now I can now rewrite it and say a squared integral of cos square theta d theta. Now from our trigonometry, we have to know how can we get this cos square theta from our trigonometry. If you can remember from our cos 2a, cos 2a in our trigonometry, that they said cos A minus sin A, and this one give me cos square A minus sin square A. And from here, that means cos 2a equals to this. And we know that means cos 2a equals to cos square A minus, sin square A is 1 minus cos square A. That means cos 2a equals to cos square A minus 1 plus cos square A. That means cos 2a equals to cos square A plus cos square A. 2 cos square A minus 1. Now, that means from here, do not forget, I'm looking for cos square theta. That means cos square A. What do I do? Let me bring this minus 1 to this side. That will cos 2a plus 1 equals to 2 cos square A. 2 cos square A. So for me to get this ordinary cos square theta in form of this cos square A, that means I will divide this out by 2. Over 2 over 2. That means cos square A equals to cos 2a plus 1 all over 2. So exactly that is what I want to bring in this case. So that means for a square integral of cos square theta d theta, that will be equals to a square integral of plus 2 theta, I'm using theta now, plus 1 all over 2. All over 2. As you can see it. That one will give us that means a square integral of cos 2 theta plus 1 all over 2, which is, if I bring, do not forget that this 2 is meant for both. So if I bring these 2 outside, it's going to give me a square all over 2 integral of cos 2 theta all over 2 plus 1. Because the 2 is meant for both, so if I bring one out, the other one will be inside. That means we are having, we're going to have a square all over 2. And what is the integration? Sorry, what is integration of cos 2 theta? Integral of cos 2 theta is going to give me sine 2 theta over 2 plus, and integral of 1 is going to give me theta. Let me use theta since I'm using theta. So that means we are having a square all over 2. And what is sine 2 theta? Sine 2 theta, it is 2 sine theta cos theta. Please try to watch the additional and product formula of the video I made on additional product formula for trigonometry. All these things will become clear. Sine 2 theta is 2 sine theta cos theta. That means 2 sine theta cos theta all with 2 plus theta. This cancels this. So I'm having a square all over 2 sine theta cos theta plus theta. So after this, what do we do? A square all over 2 sine theta plus theta. Now we are going to substitute for all these values, one after the other. Now, please do not forget from the beginning, the triangle given. But before I do that, let me use this one to open the bracket. That means a square all over 2. So I use this one to open the bracket. Sine theta plus theta plus y. That means a square all over 2 theta. Now, we now need to substitute. Do not forget from the beginning, the triangle we have is like this. We have a here, and we have x here. We have our theta here. And if I use Pythagoras theorem, I need to get this. The Pythagoras theorem is a squared equals to. And if the hypotenuse is a, opposite is x squared plus a squared. That will be a squared, if I do minus x squared, equals to a squared. If I do like this, that means adjacent is what? Square root of a squared minus a squared. It will be here. A squared minus a squared. That is the adjacent. So if I have it like that, that means for here now, a squared all over 2, what will not be the sine theta? Don't forget that the sine theta here, opposite all over hypotenuse. Sine theta is x all over a. I will substitute it here for sine theta. X all over a. And what is cos theta? Cos theta from this car, that is adjacent. Which is this? Adjacent over hypotenuse over a. So I will substitute it here. Multiply by a squared minus s squared all over A plus A square all over 2. And what is our theta? We can get our theta from here. We can get our theta from here. If I want to get theta from here, that will be theta, if you divide this out by sine, equals to shift sine x all over A. This will be our theta. That means sine x all over A. So that will be our theta plus C. But in case you want to simplify further, there is something that is common here. What is common to both? This is common, A square all over 2. That means A square all over 2 into bracket x with A square minus S square all over A square if I multiply this plus I factorize this half sine x all over A everything plus C. So that is the first example. What is the answer for that number 1? Okay, this is second example. Like I told us before that we work with sine, do not forget sec and tan. These are the 3 things we work with. Now you draw your triangle, put your theta here. When you put your theta here, the first thing is that when you see this thing like this, you see A square minus S square. Definitely, this is your hypotenuse. Hypotenuse will come first, it's the largest. If this is your hypotenuse, what will be the x like that? I told you, definitely, if you put your x here, assuming you put your x here, the only thing that join this and this together, that is adjacent of hypotenuse, that is cos. So definitely your x must be here, which is sine theta opposite all over hypotenuse, which is all over A. The sign that I have to join them together. And what does that mean? If you cross multiply x times 1 and A sine theta. The next thing you do is that after you have gotten your x equals to A sine theta, you find the x d theta. The x, you differentiate it against the theta. What is the differentiation of sine theta? That is cos theta. That will be A cos theta. And if you cross multiply, that will be dx equals to A cos theta d theta. Dx equals to A cos theta d theta. Now, after you have gotten that, you know your x, you know this, you can now substitute. How do you substitute? One all over square root A square minus, I've known my x to be A sine theta. A sine theta all square multiply by, I've known my dx. My dx is A cos theta d theta. That's my dx. So what is the next thing? After I have substituted those values, that means integral of 1 all over square root of A square minus, you know this 2 is meant for both, A square sine square theta multiply by A cos theta d theta. That means we have integral of 1 all over, A is common to the both sides. So you factorize for A square into bracket 1 minus sine square theta. Multiply by a cos theta d theta. After that, we all know that 1 minus sin square theta is cos square theta. That means it's leading us to something like this. Integral of 1 all over square root of a square 1 minus sin square theta, that is cos square theta, multiply by a cos theta d theta. After that, we are having integral of 1 all over. We can split that square root on this and this. Square root of a square multiply by square root of cos square theta multiply by a cos theta d theta. So definitely this cancel this and this cancel this. So we have integral of 1 all over a cos theta, that is a cos theta, a times cos theta, multiply by a cos theta d theta. So definitely this can cancel this automatically. That is 1. So that means I'm having what left? 1 d theta. That's what I have left. And what is the integration of 1? The integration of 1 here is going to be theta plus c, arbitrary constant. But do not forget, we have to substitute for that theta. From our triangle, we started with, I think it's a here and x here. If you remember, now theta is here. So we need to get this side by using Pythagoras theorem. Pythagoras theorem is a squared equals to o squared plus a squared. Our hypotenuse is a squared equals to opposite is s squared plus a squared. That is a squared minus s squared equals to a squared. Square root of both sides times adjacent equals to square root of a squared minus s squared. Square root of a squared minus s squared. That's the adjacent side. Now that we have gotten the adjacent side, actually, I'm not even sure we need it. We don't really need the adjacent side. We don't need it. We don't need it. Because we started from we said the opposite is, we use sin theta now, equals to opposite all over hypotenuse. So I'm looking for theta. I can get my theta here. If I divide both sides by sine over sine over divided by sine, I mean the theta is going to give me shift tan. So that means my theta is this. That means this theta will be sine of x all a plus c. So that is our answer for that. Now, the number 3 example there. Now, when you have a case like this, what do we do? That will be draw your right angle triangle here. Your theta is here. Now, if you really observe, you will see that this one is s squared plus a squared. Automatically, this will be the hypotenuse. If you use Pythagoras theorem, if you add these two sides together, they will give you something like this. So definitely, all of this thing is my hypotenuse. And do not forget, we work with tan, sine, and sec in integration by trigonometric substitution. And how will now relate? That means if I put my x here, I'll put my a here. For which I have this. Now, you may ask me, why can't I put a here and put x here? No. Because if I put A here, although I know that what we work here is tan, because opposite over intersect. That's what we work. Now, if I now put tan theta, if I put A here, let's say I put A here, opposite over x, is I'm going to have something like A equals to x tan theta. But it must not come like this. Always it must come s equals to, not a equals to. It must always come as s equals to, not a equals to. That means my x must be a all over a. That means my opposite must be x. Like this, and adjacent must be a. So I'm having, if I cross multiply, I'm having x equals to a tan theta. And you know the next thing, what we do, we differentiate it. We find if s equals to a tan theta, we find the x is theta. And the x is theta, what is the differentiation of tan theta? That is sec squared theta. That will be a sec squared theta. We now cross multiply. The x equals to a sec squared theta d theta. Now we have known this, we have known our x, we have known our dx. So we can now go and substitute. That means integration of 1 all over, because this is 1 dx, just bring the x to the back. What is my x? My x is, open a bracket, substitute it for this x. A tan theta squared plus a squared. And what is the, if you bring the s there, you say 1, if you now bring the s in. And what's my ds? My ds is a sec squared theta d theta. A sec squared theta d theta. Now, when I have this, what next? That means integration of 1 all over a squared. This will be is for this and for this, and tan squared theta plus a squared multiply by a sec squared theta d theta. So the next thing to do is that 1 all over. Now what is common here? A squared. A squared open bracket tan squared theta plus 1 multiply by a sec squared theta d theta. So after that, what do we do? Said integral of 1 all over a squared, and we know that tan squared theta plus 1, it is sec squared theta. This will be sec squared theta. Sec squared theta multiplied by a sec squared theta d theta. If you are saying how is it sec squared theta, please watch my trig identities. In the videos I make trig identities. You see the way I explain everything about how those things are becoming in. So this cancel this automatically, and this cancel this, but it remain 1a, because this is a, this is a squared. That means we are having what name? 1 all over a theta d theta. So I will give us this 1 over a, bring it out. 1 all over a integral of cancel a, we have 1 over a. I guess the sec squared theta cancel square theta, a cancel a, we have 1a left. That's 1 over a theta. So I brought the 1 over a out of integrations, and that means we are having 1 d theta. because this cancels this, that is 1. So that means what we do now is that 1 all over a, what is integration of 1? That is theta. Theta plus c. So definitely if I use this 1 over a to open bracket, that is theta all over a plus c. Plus c. Now we need to substitute for theta. We need to substitute for theta. Cannot just leave our answer like this. We have to substitute. And if I will substitute from the start of our triangle, okay, I don't need to use the triangle, because if you remember, we used tan theta this time around. We said tan theta equals to, what do we use? We said x all over, I think it's x all over a. So my theta will just be shift tan x all over a. So that means my answer will be 1 all over a. My theta will have got shift tan x all over a plus c. Now, lastly, for integration by trigonometric substitution. Now, let's take a look at this. We are having integral of 2dx s squared plus 5 as the same thing as integral of 2 all over s squared plus 5 dx. Now, if you look at this one, we draw your right angle triangle. You now ask yourself, because this one does not carry square, how can you do it? I can write it like this. So that is exactly the same thing. But this, you cancel this. So I'm writing the same thing. Because they must have square for this thing to work out. That means it has become something like this. 2 all over s squared plus root 5 squared dx. So if I put my theta here now, put my theta here, so you know that this will be our hypotenuse automatically. This will be our hypotenuse. That is s squared plus root of 5 squared. So that means our opposite will be x, and our adjacent is going to be root 5. So that means it's tan that we're going to use. That means tan theta is going to be opposite all over root 5. So if I cross multiply, that will be x equals to root 5 tan theta. So if I find the s d theta, that will be root 5 sec squared theta. Because the differential of theta is sec squared theta. Now you cannot substitute. I substitute now. So that means I always substitute integration of 2 all over, what is my x? My x is root 5 tan theta. I'll substitute it here. Open bracket, root 5 tan theta all square plus root 5 all squared. Now, what is my dx? So if I cross multiply here, that means my dx equals root 5 sec squared theta d theta. So that means it's going to give me root 5 sec squared theta d theta. So the next thing to do now is that integral of 2 all over, you see this one is meant for this and it's meant for this. Root 5 square, square, we cancel the square root. So we are going to have 5 left. And this one will be tan square theta. Plus, this also will cancel this plus 5. Multiply by root 5 sec square theta d theta. So normally 5 is common here. 5 open bracket tan square theta plus 1. Square root of 5 sec square theta d theta. So the next thing we do is that the integral, I can bring out this 2 over 5 out. 2 over 5, that is 1 all over. So the tan square theta plus 1, that is sec square theta. Sec square theta multiply by root 5 sec square theta d theta. So sec square theta cancels sec square theta. So that means, let me bring it inside that. 2 all over 5 multiply by root 5 d theta. Now, so getting here, I just said 2 root 5 all over 5 d theta. You can apply math, just say our knowledge of indices. This will become 5 raised to the power 1 all over 2 all over 5 raised to the power 1 d theta. So that means we are going to have 1 all over 2, they are the same, just minus it. Theta. So that means we are having we are going to have 2 integral of 5. We find the LCM here, that is 2. That is 1 minus 2, that is minus 1. Minus 1 theta, that is 2 integral of 1 all over 5 raised to the power 2 d theta. So that will give us 2 integral of 1 all over, it means root 5 d theta. But lastly, we have to integrate it. In fact, for us to integrate it, that means 2 integration of, if I bring this up back, it will give me 5, 1 minus 1 all over 2 minus, but if I bring it up back, minus 1 all over 2, integration that is plus 1, all over minus 1 all over 2 plus 1 all over 1. According to our law of integration. So that means we are having 2 open bracket 5. The LCM will be 2. 2 into that is 1, 1 times minus 1, minus 1, plus that is 2, all over minus 1 plus 2, that is 1 over 2, because what we have here is what we bring down here. So we are having 2 open brackets 5 raised to the power 1 all over 2 all over 1 all over 2. So that will give us 2 open brackets. That is 10. Now when you, that will be 10 Like if you said this one is root 5 divided by 1 all over 2. That's what I'm trying to say. So that will be 2 open brackets root 5 times 2 all over 1. So that will be 2 into bracket 2 root 5. So lastly, we are having 4 root 5 plus c. 4 root 5 plus c. We have an integral question like this under the trigonometric substitutions. What we do is that, okay, this, we notice that this 5, our question cannot come like this because this 5 should come in form of a square so that we can be able to apply our tree. Now, if you draw your right angle triangle, like what I said, and I told us that we are working with tan, sine, and sec. Now that means, what can I do with this 5 that will make it to stand in form of square? Now this 5 I can also write like this: root of 5 square is also the same thing as this. That means I can rewrite it, these questions, I can say integral of 2 dx all over s squared plus root of 5 squared. It's still the same thing as if this one will cancel this and it will give us 5 back. Now, when we now have it like this, that means all of these things will be at the hypotenuse side, because according to our Pythagoras theorem, h squared equals to o squared plus a squared. If you add it together, that means h squared will equals to something like this. So that means our h squared is this, which is s squared plus our root 5. Our root 5, if everything is here. Now, if I put my theta here, that means my opposite is going to be x, while my adjacent is going to be root 5. You should not forget that. Not forget that. Now, what am I going to use out of these 3? I'm going to use tan, because tan is the one that link this one and this one together. Opposite all over adjacent, not sine, because sine link opposite over hypotenuse, and the sec is inverse of cos. That is cos is car, adjacent all over hypotenuse. That is hypotenuse all over adjacent. So which is this? So it's only tan that can work there. So that means I will write my tan theta equals, and I told you, why do I know that this x will be here? Because it will always be like x all over something, not something all over x. It must always stand like this. So that is why I know that my x will be the opposite. Now, if I cross multiply, that means my x will be what? Root 5 tan theta. And I will have to get the x. I need to get the x from here. That means my dx d theta, my ds d theta is going to give me root 5 sec squared theta. Your tan theta is sec squared theta. So that means by cross multiply, that means dx will give me root 5 sec squared theta d theta. So that is what my ds will give me. That means from that, we can now write like this: integral of 2 dx, no, integral of 2 all over s squared plus 5 all squared multiplied by. So our ds is now what? Our ds is now root 5 sec squared theta d theta. So that's our ds now. Our ds has come to this, our 2 and our this. And also, we have known our x. We have known our x. That means I can also write like this: integral of 2 to bracket root 5 sec squared theta d theta all over, what is my s? My s is root 5 tan theta. That means root 5 tan theta all square plus root 5. You know, if I say this thing, we still cancel this, it's going to give me 5 automatically. That means I'm going to have something like this. Integral of 2 into bracket 2 into bracket root 5 sec square theta d theta close bracket all over. This square is for this, and this square will cancel the square root. That is 5, and this square is also for tan theta. That is tan square theta plus 5 plus 5. And what is that? So that one is giving me something like this: integral of 2 all over 5 to bracket square root of 5 sec square theta d theta. Now, if you look at this, there is something that is common here. 5 is common here. I can factorize for 5. 5 open bracket tan square theta plus 1. Now 5 is common. I bring out the 5 that is common. It is remain tan square theta plus 1. So after that, what do we do? So that's, we are having integral of 2 into bracket square root of 5 sec square theta d theta all over 5. What is tan square theta plus 1? That is sec square theta. So definitely this sec square theta cancels sec square theta. So we are having integral of 2 all over 5 square root of 5 d theta. Here. That's all we have left. So after that, we are going to have something like this. I can just say 2 integral, I brought out the 2, that is root 5 all over 5 d theta. Now I can now apply my indices. I can just say 2 this one is 5, this power 1 all over 2 minus 1. Because this one is 5 raised to power 1. If I bring out the 1, because they are having the same base and that is 2 integral of 5. Don't give me the LCM is 2. 1 and 1 minus 2, that is minus 1. Minus 1 all over 2. So I can now integrate this. In fact, I can just say 2 into 1 all over 5 d theta. This will give me this. If I take away the minus, negative index, this minus it will become this, which is also the same thing as 2 integral of 1 all over root 5 d theta. What can I do now? I can just say I can bring out this root 5. I can say 2 all over root 5 integral of 1, which is which is going to give me 2 all over root 5, and this one is theta plus c. But we cannot just leave it like that. We have to substitute for theta. And if you can remember, we used tan theta from the beginning. The tan theta equals to, if I will not forget, I think we use x all over root 5, square root of 5. So if you divide both sides by tan, that means our theta is going to be tan inverse of x all over root 5. So I'm going to substitute that for that. That means 2 all over square root of 5 multiplied by what is tan? What is our tan? That is shift tan x all over root 5 plus c. Plus c. So that is the answer for that. Lastly, under the integration by trigonometric substitution. Now, lastly, under the integration by trigonometric substitutions. Now, this one might look like integration by partial fractions, but it is not, because you cannot split this one into fractions, into partial, because this is plus, it's not minus. Add it being it is minus 4, you can say 2 raised to power 2 and say x plus 2, x minus 2, and you now start applying integration by partial fractions. But in this case, we are still going to use by trigonometric substitution. And when you are when you fix with this, how do you do it? You just do like this. Integral of, you split it, 2x all over x squared plus 4 dx plus integral of 1 all over x squared plus 4 dx. So this is it. You are going to simplify like this. Like this 2x all over this plus 1 all over everything. So after you've splitted it like that, now let us look at this. There is a particular integration that says that if the differentiations of the denominator is going to equal to the numerator, we are just going to link it or log it. Now look at this x squared plus 4. You will notice that differentiation dx of x squared plus 4 will actually give me 2x, because this one will turn to 0 and this one will be 2x. If I differentiate this, it's going to give me 2x. So that means what I just need to do here is that I just limit. I'm saying we split this for this and this for this. That's what it's now. And the differentiation of this give this. So whenever it happens like that, you just limit. Assuming this is the only questions given to us, and you have done it like you just say plus c. That's your answer. Now because we have this also plus, so let us now go and work on this now. For integral of 1 all over x squared plus 4 dx. So that means we can now start doing draw our triangle for that. That means because we can rewrite it as integral of 1 all over x squared plus 2 squared dx. And you have known that this will fall into hypotenuse. So we are going to use tan. We are used to that before. Tan theta. And when we use tan theta, it's going to be x all over 2. X all over 2. That will be x equals to 2 tan theta. And our x, so our dx d theta is going to give us 2 sec squared theta. And that means dx equals to 2 sec squared theta d theta. That's what we are going to have. So that shows that we are going to have integral of 1 all over, we have known our x is 2 tan theta. 2 tan theta square plus 4. Now 2 square is still 4. So definitely, and our dx, what's our dx? Our dx is 2 sec square theta d theta. So that's our dx. So definitely we are having something of this nature. That means integral of 2 sec square theta d theta all over, no, 2 square is 4. 4 tan square theta, this square is for this and this, plus 4. That means we are having integral of 2 sec square theta d theta all over, what is common here? 4. 4 open bracket tan square theta plus 1. That means integral of 2 sec square theta d theta all over 4 open bracket tan square theta plus 1, that is sec square theta. Sec square theta. So definitely this, we cancel this. 2 here 1, 2 here 2. So we are having 1 all over 2 integral of d theta. So that means integral of theta, that is 1 all over 2 theta. Integral of theta is theta plus c. So we can now join this answer together with this. We should not forget we split this from the beginning. So that means the whole of the thing is going to, we are going to have lim s squared plus 4 plus 1 all over 2 theta plus c. But do not forget that we have to substitute for this theta. You cannot just leave your answer like that. And from the start, we use tan theta. We have tan theta equals to, I think we use x all over, I won't forget, x all over 2. So if I divide this out by tan, that means theta equals to shift tan x all over 2. That means my final answer will be lim into bracket s squared plus 4 plus 1 all over 2 multiplied by shift tan x all over 2 plus c. So that is final answer for that. So please make sure you subscribe to this channel and like, and you put your comment in the comments. You put your comment in the comment section in case you have any inch about this, and make sure you share it. Thank you.